Today we're doing another example from section 3.7. Jacob, hope you're feeling better. Anyone else who's viewing, welcome. So, Janae's here. Hi, Janae. She won't speak. Today we're looking at an ellipse that can be modeled by the equation x squared minus xy plus y squared equals 7. And specifically, we're going to look at a line that is tangent to that ellipse through the point -1, 2. We're going to find an equation for that line. But wait, there's more. We're also going to find the equation of the line that is perpendicular to the tangent line, going again through the point -1, 2. And we're going to bring in a new term today called the normal line, which is the same thing as a perpendicular in just a little different reference. But often if you're in an engineering situation, they'll call it the normal line. So we want to broaden our vocabulary a little bit. So we're going to find an equation for the normal line, tangent line, or I'm sorry, perpendicular line to the tangent, and the tangent line itself, all through the point -1, 2, and all in reference to this ellipse, x squared minus xy plus y squared equals 7. Now, as we discussed yesterday, this model, this equation, is not explicitly written. It's implicit. But that doesn't scare us. We can derive an implicit function. Well, this is a function, an implicit expression, just like we can an explicit expression. So we know that the slope of this tangent line to the ellipse can be found by taking the first derivative. So let's do that. So we have so we'll take the derivative here, dx, the derivative of x squared with respect to x, minus the derivative of xy with respect to x, plus the derivative of y squared with respect to x. Now notice, this is in terms of y, it's y with respect to x, so we'll have to be cautious there. Equals the derivative of 7 with respect to x. Okay, moving onward and upward. So this one's not too bad. That's just 2x minus. Now notice xy is x times y, which means it's a product, which means we need to use, you guessed it, the product rule. So we can say minus, okay, product rule, the first times the derivative of the second, y dx, plus the second times the derivative of the first. And I'm going to write dx dx, and I know that seems a little bit unnecessary, but I think it's good to go through the process. Notice I put these two in parentheses, and I'll distribute my negative sign a little bit later. It's important not to lose that. Then we can go plus 2y dy dx. Because again, when this is in terms of y as a function of x, we have to use the chain rule. So 2 times y is the derivative of y squared, and then dy dx here. And then the derivative with respect to x of 7 is 0. Okay, so let's keep going and clean this up a little bit. So we get 2x minus x y dx minus y dx dx is 1 plus 2y dy dx equals 0. Now notice that I have a dy dx term here and a dy dx term here, so that's good. I want to keep them together because my goal in the end is to get the derivative of y with respect to x. That will be the slope of the tangent line. So to begin with, then, I'm going to try to subtract out the 2x and add the y to remove them. So we will then get the opposite of x dy dx plus 2y dy dx equals y minus 2x. Okay, that should work. And notice right here we have a dy dx in both terms, so we can factor that out. dy dx dy dx times quantity 2y minus x. Again, you could have said negative x plus 2y. It just seems like a convention in most applications. You'll see where they put the positive term first. A little bit simpler, but I just put it first. The negative x is still here. So we have dy dx times the quantity 2y minus x equals y minus 2x. And then we'll divide both sides by 2y minus x, leaving us with dy dx equals y minus 2x over 2y minus x. Very nice. Very nice. Okay, so now we've found the slope of the line that is tangent to the ellipse. So let's find the equation for that line. Keep in mind, I guess we should back up and review it a little bit. We just found that the slope of that line is, oh, no, I take that back. We just found the equation, the derivative. Let's put it specifically in the tangent line at negative 1, 2. This part here would give us the slope at any x order here. So let's evaluate dy dx evaluated at negative 1, 2. That would equal 2 minus 2 times negative 1 over 2 times 2 minus negative 1. Watch my signs. So dy dx evaluated at negative 1, 2 equals, oh, let's see, 2 minus, and that's 4, and 4, 5, 4/5. Okay, so that's 4/5, and we know that the point negative 1, 2 is on that line. So we can say y equals, we can use slope intercept form. We can say, well, y is 2 equals, slope is 4/5, and x is negative 1 when y is 2 plus b. Now b is our only unknown, so we can solve that. And we can say 2 equals negative 4/5 plus b. So we're going to be adding 4/5 to both sides. So we can say that that is 8/5. No, not that. We can say that's 10/5. That's better. Plus 4/5 equals b. So that's 14/5 equals b. Therefore, our equation will be y equals 4/5 x plus 14/5. So let's see if that makes sense. 14/5 is almost 3. So our slope of 4/5 definitely makes sense. And if this is up to, yeah, that makes sense. Pretty much makes sense. Okay. So that one seems like it works. So next we need to find the equation of the normal line or perpendicular line. And we know from way, way, way back when that the slope of a perpendicular line is the negative reciprocal. So 4/5 and -5/4. Equals -5/4. So once again, we can say y equals mx plus b, and we can say 2 equals -5/4 times -1. And again, I'm using the order pair -1, 2 that we started with in the beginning plus b. So now I can say 2 equals positive 5/5 plus b. You know what? I think it might be life easier to call it 2 8/4. And so then I can subtract 5/4 from both sides. 8/4 times 5/4 equals b. And then get 3/4 equals b. So now y equals my slope of -5/4 x plus 3/4. Once again, let's go back up to our drawing and see if that makes sense. Is the slope of -5/4 reasonable here? Yes, probably for this drawing. It's not to scale. And is a y-intercept of 3/4 reasonable here? Very much so. So I think our two lines are good. Good to go. We have the line that is tangent to the ellipse, x squared minus xy plus y squared equals 7 at the point -1, 2. And we have the equation of the line that is normal to the ellipse x squared minus xy plus y squared equals 7 at the point -1, 2. And that was y equals 4/5 x plus 14/5. And over here, y equals -5/4 x plus 3/4. Okay, that's all I have. I hope this is helpful, and get well soon. Bye now.